Hello ladies and gentlemen, welcome back. This video tutorial is for students who are in Geometry Goal 4. We've got taken care of all of the basics. We understand how similar polygons work. And now that we understand how they work, we're going to get into the mechanics of them working before we start getting into the real meat, which is one of Ms. Dubois' favorite sections in geometry. It's not quite as beautiful as triangle congruence, but it's pretty high up there. So next up, now that we understand how this works, we're going to be focusing in on something called dilation. So if any of you guys have ever had to go to the eye doctor and you've had your pupils dilated, then you know what dilation means. That means you're making something bigger or smaller, making bigger or smaller. So when you go to the eye doctor, you dilate your pupils, you make your pupils bigger so that they can look in and see if everything is kosher and up to snuff. So in a scale model, they tend to tell you right off the bat, it is 1 centimeter to 1 inch. And since you want to keep, you don't use them, but you kind of want to keep your units of measure in your fractions so that you can match accordingly, because again, matching is a big thing. So in the scale model, the height of the TV is 9 centimeters. So gee, that 9 centimeters, am I going to put it up here or am I going to put it down here? Well, since we're playing a matching game, you leave it up top. And then it's the unknown over here. So it's going to be 1 centimeter to 6 inches. So cross multiply. So it's going to be 54 inches. I almost wrote 56. Good job, Ms. Dubois. Now, new proportion. What do they tell you? They tell you that the length of the real television is 48 inches. Again, you want to put it where it matches, so 48 inches is going to go here. So there's our x. What does that mean? If I cross multiply, that means 6x equals 48. Divide by 6, divide by 6, x equals 8. So it'll be 8 centimeters in dimension. Next up, we have 1 inch to 9 feet. And now what do they tell you? 10 inches to our unknown, cross multiply. So it's going to be 90 feet in scale. Next up, what do they tell us? Let's see here. It'll be 63 real feet. So cross multiply, 9x equals 63. Divide by 9, x equals 7 inches. That's all you're really doing here. You're getting you used to where your x goes in the proportion. That's what they're trying to get you used to. That's what they're trying to prep you for this topic. And once you're comfortable with that, now they give it to you and they don't actually give you the whole thing. Let's see here, scale. So scale of a painting and find the scale factor. So the scale factor, what that means is what is your ratio, okay? And then you want to be careful, scale factor of the drawing to the real painting. Since drawing is listed first, that's what goes on top. And then to the real painting is going to be 24. So your scale factor, it is 1/4 scale. That's what they mean when they say scale factor. If it's a fraction, you're going smaller. If it's a whole number, obviously, you're going bigger. Over here, and now let's double check. If the drawing is 5, the painting is 20, so it is also a 1/4 scale factor. Okay, we're consistent. Just checking our work. Next up, we want the scale factor of the model to the real sculpture. So model goes on top, the sculpture goes on bottom. 9/30, those are both divisible by 3 by 3, 3/10. Let's see if the rest of it works. 6/20, divide by 2, divide by 2, so far so good. 12/40, let's see, divide by 4, divide by 4, Ms. Dubois, pay attention. So yes, this all matches up and is going to be a scale of 3 to 10. Okay. Next up, we're going to use all of that knowledge to start actually doing some math. So here we have 2 centimeters represents 5 meters. Find the area of the dining hall. So the dining hall, we need to now figure out what's the area in centimeters. That is length times width. So 2 times 4, this is going to be 8. So if this is 8 centimeters, then what is it going to be in terms of the meters? That's where your setup comes in. So 2x equals 4t, divide by 2, x equals 20 meters squared. That's what you're looking to be doing here. Here, find the area of the real backyard, and there's the important information. 1 centimeter, 3 meters. The backyard is, since when does an apartment have a backyard? How does that logic, anyway? Let's see here, what's the area? 3 times 4 is going to be 12 centimeters over x. So x equals, oh, we got lucky, 36 meters squared. That's going to be your answer. So again, they tell you the proportion, and then you can find your area and figure it out that way. Next up, determining, these two are hard because I can't really, they're manipulative, so I can't really move it around. What you're doing is you're taking your little scale and you're shifting it left and right until you get this shape to wiggle its way around to this shape and figuring out how you do it, okay? So for example, this one is not possible, and I say that because it is the exact same shape. I am not scaling up or scaling down. This one, however, as I scale it up, this will eventually fit into here perfectly, and then it will have an actual scale factor. So if we have 2 here, 2, 4, 6, 8, this is a scale factor of 4. Next one, same idea over here. Draw the image of the following triangle after a dilation centered at the origin with a scale factor of 1/2. What that means is you are going to be taking each coordinate here. So let's go through them. This is 8, 6. We're going to do 8, 6. We're going to multiply it by 1/2, multiply it by 1/2. So our new coordinate is going to be 4, 3. 4, 3. Next coordinate is going to be 12, 8. So 12, 8 times 1/2 times 1/2. So our new coordinate is going to be 6, 4. 6, 4. And then our last one, what's this one? This is 8, 10. So 8, 10 times 1/2 times 1/2. We're going to get 4, 5. 4, 5. And you can kind of see, I mean, my drawing isn't perfect, but you can see that it's the exact same shape. We just made it a little bit smaller by always multiplying by what your scale factor is. Next up, a little bit more. Again, now we have circles. Circles are always going to be similar to each other. I assume that's obvious because of the nature of the shape. But again, you're going to take your circle and then manipulate it around until it fits into the other circle. Take your circle, manipulate it around until it fits the other circle. That's pretty straightforward. And then, from there, you're just filling this in. Is the original circle similar? Yes, circles are always similar. So next up, translate the solid circle. So we're going over how many and down how many. So we're going to be going right by 2 units and then down by 2 units. That's what they're looking for. And then what is dilate the solid circle by a scale factor of. So the solid circle is getting smaller, so it's going to be 1 over something. What's my radius here? 1, 2, 3, 4. And what's my radius here? 1. So 1/4. There are your 2 numbers. Over here, fill in the blanks. So translate the circle. So we are going to be going We are going to be going right by 4 units, and then we're going to be going up by 2 units. Dilate the solid circle by a scale factor of. So this is the solid circle. Okay, so this one we're going bigger. So it's going to be a factor of 1. And then what's the radius here? 1, 2, 3, 4. It's a factor of 4. And that's everything there is to know about scale factor and dilation. Now that we understand how all of this works, we're going to start digging into the meat of the chapter, which is basic trig, also known as SOHCAHTOA, which we'll be talking about more in the next video. As always, stay happy, stay healthy, stay safe. I'll see you in the next one.